So, hi everyone. I think we'll start after a couple of minutes, waiting for the students to join in. I think then we'll be ready to go. So, I think we'll just wait for another 1 minute, and I think then we can start. I think we should start. Yeah. So I welcome you all to this live problem solving session number 3. So let me give you my introduction first. My name is Musa Abrufi. I'm a PhD student in the Department of Electrical Engineering at IIT Kanpur. We carry out this TA duty as a part of our PMRF deliverables. So the course is Digital Circuits, and the course instructor is Professor Shantanu Chattopadhyay from IIT Kharagpur. So far we have covered 2 live sessions. Now we will shift our focus to live session 3. So this live session will be based on the topic combinational functional minimization and K-map, where will be solving logic minimization, finding equivalent functions, mostly using K-maps, and also some algebraic manipulation as well. Also, I put some basic logic gates here in as well, but logic gates will be extensively covered in the next week, that is week 4. So today is our focus on week 3 material. Now let's start with the first problem of today's live session. Just focus on the problem first, then I'll discuss the other part. So the problem is stated as, given the Boolean function f of abcd equal to sum of minterms 4, 6, 7, 10, 11, 12, 14, 15. We need to find its equivalent function. So using K-map, we'll try to find its equivalent function. So before we proceed, let's just construct a 4 cross 4 K-map. So here I have already drawn up for your reference. I'll again make it here a smaller version. We have a square. Since it is a 4 variable function, we will have a 4 cross 4 K-map like this. And here I have written AB and I have written CD. Then I'll mark all the terms here. This is termed as A bar B bar. This is termed as A bar B. This is AB and this is AB bar. Then this is C bar D bar. This is C bar D. This is CD and CD bar. So let me highlight this part and this part and this part and this part. Keep this in mind. People usually get confused, although they know it, but sometimes in a hurry they try to mix up the two. So now we have the terms. We'll write the corresponding minterms. Here at this position we have 0, here at this position we have 1, then we have 2 here, right? Keep this thing in mind. And we have 3. After that we have 4, we have 5, similarly 6 here and 7 here, and then we have 8 here, right? Here 9 here, 10 here, 11 and 12 here, 13 here, 15 is here, mind it, 15 is here and 14 is here. Now we have the corresponding minterm values as well. Now we need to minimize the function. So the function is equal to sum of minterms 4, 6, 7, 10, 11, 12, 14 and 15. All of those minterms which are in the function, we'll mark them with 1. We'll write 1 at their corresponding positions. So we have 1 at 4, we have 1 at 6, we have 1 at 7, we have 1 at 10, we have 1 at 11, we have 1 at 12, we have 1 at 14, and then we have 15. So I'll just count all of whether I've taken all of them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I have taken all of them. Now what we need to do, so while minimizing a function using K-map, since it's a 4 cross 4 K-map, we'll try to find the largest implicant here. So for that, we'll first look whether we can make an octet. So octet is a shape that will cover the 8 of the minterms. So by looking at it, I know I cannot cover the minterms using an octet. Now what is the next possible? The next possible is chord. So I can see I can make chord here. So for this, what I will do, I'll first take a chord and I will use different colors to avoid any confusion. I have this chord covering the minterms 6, 7, 15 and 14. So this is my chord 1 here, and the term corresponding to this will be, let's take a look at here first. So B is not changing, we will come here, and here C is not changing, so it will be BC. The contribution coming out from this chord will be BC. Now we'll take look at another chord that is here, covering the midterms 11, 10 and also 15, 14. So we will have this chord, and we will take a look at this contribution. It's A, because A is not changing, and it's again C, as we saw earlier, because C is not changing. So that contribution from this term will be AC. Then we can construct another chord. Then we can construct another chord like this, and the contribution coming out from this will be, B is not changing, it will be B and D bar, right? So ultimately my function will be equal to F will be equal to AC plus BC plus BD bar, that is this term and this term. So this will be my F, and this is equal to your option C, as rightly written by one of the students. So this was your question number 1, which was a 4 variable function, and we needed to minimize it using a 4 cross 4 K-map. Any doubts in this question? I think this was a pretty straightforward question, but if you have any doubts, please let me know. If not, then we can proceed to the next question. So the next question, I think this is not visible for you guys. Let me just, I think now it's visible. Yeah, I think it's visible now. So the question asks us, minimize the sum of product expression for f of w, x, y, z shown in K-map. So the K-map, they have given it with ones and zeros, and then we need to find the minimize sum of product expression. So this is along the same lines as was the previous question. Now there is some one difference, I'll come to that. So let me just draw the K-map here first. So first we need to take care of this thing, that your x and y are your y and z are your MSBs that are written here as per the given question, and w and x are written here. So this will be 0, 0, 0, 1, 1, 1, 1, 0. That corresponds to W bar x bar, W bar x, W x, W x bar, and here again 0, 0, 0, 1, 1, 1, 1, 0. It will correspond to Y bar Z bar, Y bar Z, Y Z, and Y Z bar. Now the given is 1, 1. I will not write zeros because they are of no interest to me, as it's a sum of product expression that I am looking at, and 1, 1. Now I have some different terms here, different markings that are x here, x here, x here. Can anyone write in the chat box what are these called? These x, can anyone tell me what are these called? Yeah, they are called don't care. Thank you. So these are called don't care. Now the question asks us to minimize the given K map, the expression, find the minimize SOP expression. So what we will do, we'll again look for whether we are having any chord or not. By looking at the K map, I can see there is no chord, that can fill them in terms. Then I look at the octet. So the octet that I can construct is 1 1 like this. See, this is a chord, and the contribution coming out from this is z bar is not changing and x is not changing. So it is x z bar, right? Now I can make another chord that will cover these two ones, but these two ones will be covered with the help of the don't care condition. So using don't care conditions, I will make this chord. And the contribution from this will be, so z is not changing and x bar z. So I have these two terms. So my final expression will be f will be equal to this term and this term. So it is xz bar plus x bar z. So that is your answer, and this corresponds to option B. Any doubts? If not, we can move to the next question. That is question number 3. So the question number 3 asks us, let me just, question 3 asks us the PO's expression, that is product of sum expression, f equal to x times y plus z times x plus y plus z is equivalent to SOP expression. So we need to find out its equivalent SOP expression. So what we will do, we can do it by easily doing algebraic manipulations. Let me first write the question. So this is the question where f is equal to x times y plus z times x plus y plus z. Now I can simply use the operation xy plus xz times x plus y plus z. Now again reduce it, xy times x plus xy times y plus xyz. Then I have xz times x plus xz times y plus xz times z. Now, can anyone tell me what will be this equal to? Xy times x, and which property I am using here? Xy times x. What will xy times x will be equal to? Xy times x will be equal to xy, correct. So the property that I am making use of is a times a is a, right? Similarly, xy times y will be xy, xyz will be xyz. Then again, xz times x will be xz, x it will be xyz plus xz. Now the question arises over these two terms. What is the term xy? Yeah, we have xy plus xy, right? We have xz plus xz, and we have xyz plus xyz. Can anyone tell me what will be xy plus xy equal to? Yes, it will be equal to xy. Similarly, xz plus xz will be equal to xz, and xyz plus xyz will be equal to xyz. Now writing it like this. So the property that we made use of here was a plus a is equal to a. That is a or with a is a, and a and with a is a. So ultimately I will have xy plus xyz plus xz. That is your option C. That is the correct answer. Now I've seen some people writing A, some people write okay, okay. I think you are writing you meant A times A equal to A, right? Or A plus A. Okay, okay, got it. I You were referring to the property, right? Yeah, I got it, got it. So any doubts in this question? Okay, the answer is C. Option C is correct. Can you simplify it further? Mhm. See, what I have done here is, okay, yeah. So let me just show it. This is given as f is equal to x times y plus z times x plus y plus z. Then I have taken it here and simply done the multiplication. Xy 1 plus z is 1 xy plus xz xy. Yeah, it can be reduced further. Yeah, correct, correct, correct. You're right. It can be written like this xy and it will be 1 plus z plus xz. Then it will be equal to xy, z plus 1 is z and then it will be xz. Right, correct. Then option 1 is also correct. But I think both options can be considered as correct, right? It's not saying as minimized. Yeah, that's true. I got your point. But even option C is correct. If it should have been written as minimized SOP expression, right? Then option A is correct, right? You're correct. Yeah, option A is correct then. So I think this is kind of in ambiguity. I'll check my notes and look at it and tell you what to do in this scenario. What should be marked as correct option? Because this was from one of the assignments of I think last to last year. I'll check their solution what they had given. So other than that, yeah, it's right. So minimized will be xy plus xz. You are right. Thanks for pointing out. Yeah. So both are correct. I'll check their solution. What was their official solution? I need to dig out some these solutions from I think 2021 or 2022. I don't remember in which year they had given this assignment. So, but I'll check it. Now we'll move to question number 4. So this is a question number 4. I'll ask you guys to do first, and then I'll show you the solution. So the question asks us minimize the following Boolean function f of a b c d that is equal to sum of minterms 0, 1, 3, 5, 7, 8, 9, 11, 13, 15. So you need to minimize the following Boolean function. So I'll give you 5 minutes. I think in less than that time you'll be able to do it, and you can type in your solution. So the question asks us to minimize the following Boolean function. Mhm. Yeah, I can see some of the answers. Waiting for others to also type in. Yeah, I can see most of you have done it correctly. I'll also show the solution. So this is a four variable system. I will construct the 4 cross 4 K map first. Here I will write A, B, and here I will write C, D. So this will be A bar, B bar. This will be A bar, B. This will be A, B, and this will be A, B bar. This will be C bar, D bar. This will be C bar, D. This will be C, D, and this will be C, D bar. Right. So this is 0. This is 1. This is 2. This is 3. This is 4. This is 5. This is 7. This is 6. This is 8. This is 9. This is 11. This is 10. This is 12. This is 13. This is 15. And this is 14. Right. Now I will write the min terms that are 1. So it's 0, 1, 3, 5, 7, 8, 9, 11, 13, 15. So these are my min terms. Now I'll look for a octet, whether I can construct an octet. And having a look at this K map, I think I can make an octet. So by taking these 8 min terms, I am having an octet, and the contribution from this octet is, so AB is changing and only D is not changing, so it is D. So now these two minterms are left, 0 and 8. So I can cover them with a chord. So the chord will be like this. And the minterm corresponding to this chord will be B bar, and C bar, B bar, C bar, right? So my final expression, minimized expression will be F is equal to B bar, C bar, that is this, plus D, that is this. That is option B, as many of you have written it correctly. So this was question number 4. Now we'll move forward to question number 5 of today's live session. The question states as, minimize the Boolean function f of a, b, c, d equal to sum of minterms 1, 3, 4, 6, 7, 8, 9, 11, 13, 15 and the this term. So what is this? Can anyone tell me what is this? Yeah, they are the don't care conditions, correct. So these are the don't care conditions. Yeah. So again we have a 4 variable system. We'll again construct a 4 cos 4 k map. This is A B, this is C D, this is A bar B bar, this is A bar B, this is A B, and this is A B bar. C bar D bar, C bar D, C D, and C D bar. This is 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. Now I'll mark all those minterms present here in with 1. So it's 1, 3, 4, 6, 8, 9, 11, 13, and 15, right? And also we have the don't care conditions. So how are don't care conditions marked in the K-map? We have done it earlier as well. We saw it earlier. How are the don't care conditions marked? Using X. Using X. We write X. We saw it here, right? We mark it using X. So we'll mark the don't care conditions 0, 2, and 14. Now we need to look for octet. So can we have an octet here? I don't think I can have an octet here. So let's construct a chord first. So we will have a chord covering the minterms this. So the contribution from this chord will be AD. Then we can have another chord covering minterms 1, 3 and 9, 11, and the contribution from this will be B bar, as B bar is not changing, B bar and D, B bar D. Then I have another chord here. I have another chord here. Let me just use some different color for that. I have another chord here that covers the minterm this and this, and the contribution from this is A bar is not changing, and D bar, A bar, D bar. And finally now this is left, minterm 8. So can I cover this minterm 8? Yeah, I can cover this minterm 8 using a chord. Let me use this color. So this will be like this, and taking help of don't care, I'm able to construct a chord, and the contribution from this will be B bar and C bar, right? B bar, C bar. So finally my function will be equal to, what will be my function equal to? Sum of all the terms are this. So F will be equal to AD plus B bar D. So AD plus B bar D plus A bar T bar plus B bar C bar. So is there any option with this? AD plus B bar D, AD plus B bar D, AD plus B bar D plus A bar D bar plus B bar C bar. So option A. Option A is my correct answer. So this is your correct answer. Any doubts in this question? I didn't see any answers in real time. I thought some of you were just giving answers. Basically, I think you people will have solved this at your place, but sometimes you have to match your answer with the option as well, right? So that's why maybe it was taking a bit time and getting complicated for you guys. Otherwise, it's a pretty simple question. It's just which don't care conditions to use so that we'll get our answer exactly to the question, exactly to the options. Otherwise, the methodology I know, you guys know, because similar questions were there in the previous problems and you were able to solve them correctly. Now this was question number 5 here. So I think now we can move forward to question number 6. So this is again a question for you guys. I think it should not take more than 2 minutes. So the question asks, we have given a circuit that is shown here in a schematic, and you guys are to ask to find the output of this circuit. So which logic gate does it represent? So do it and write your options, and then I'll show you the solution. So I'll read the question. The output of the logic circuit given below represents dash gate. So you need to find out which gate does the following circuit represent. I'll just give you a couple of minutes, then you can type your answer. So I see two different answers. Anyone? Anyone else? Yeah. So now let me just show you the solution. So let's just draw the circuit below, and let's go step by step. So what is this gate? This is a NOR gate right here, two input NOR gate. So I know what the functionality is, but let's just go the step by step. So you are giving same input to the NOR gate, so it's basically A plus A complement, right? This is B plus B complement, and if you reduce it further, it will be A complement. Just a second, I need to reopen the file. I think there is some internet issue. Are you able to hear me? Am I audible? Yeah. So I think there is some internet issue with my iPad. Let me just check it. What is happening with this? For some weird reason, it got hanged. Yeah, sorry about the hiccup. So, yeah, I knew video was not clear. I think it should be clear now, right? Is it clear now? Can anyone confirm? Yeah, actually there was some internet issues with my iPad, so let me just write it here again. So this will be A plus A times this and B plus B times this. This is A complement dot A complement, and this will be B complement dot B complement. So this will be A complement and this will be B complement. So basically what it does, it when you take a two input NOR gate and give same input to its give the same input at both the terminals, the output it is basically a NOT gate. So whether you take a NAND gate or whether you take a NOR gate, you apply common input to both the terminals A and B, the output is complement, right? So this right here is A complement, this right here is B complement. Then these inputs are again fed to a two input NOR gate. So this will be A complement plus B complement whole complement, right? And using De Morgan's law, it will be A bar dot B bar. So it will be AB, right? So up to this point, my output is AB. And now this AB is given as an input to the two input NOR gate. So AB is given as an input to the two input NOR gate, and we have Q. So Q will be equal to AB plus AB whole bar. So it will be AB bar times AB bar, that is AB bar. And this is your NAND. You could have easily written here. So AB, what it does is it's basically an inverter. So AB and this will be AB complement. That is the D, option D, NAND gate. So by the way, what are NAND and NOR gates known as? They have a very particular name, NAND or NOR gate. What is that called? Yeah, universal gates. Because using these two gates, you can construct any other logic gate, right? Yeah. So this was question number 6. Now we have question number 7. And so the question number 7 asks us, which one of the following gives the simplified sum of product expression for the Boolean function f is equal to m0 plus m2 plus m3 plus m5, where m0, m2, m3 are minterms corresponding to inputs a, b, and c, and a is the MSB and c is the LSB. So this is a three variable function. So it will be a K map for a three variable system made like this. And here is your MSB, that is A, and here are your other terms where C is the LSB. So this will be A bar and this will be A, this will be B bar C bar, this will be B bar C, this will be BC, and this will be BC bar. This is 0, 1, 2, 3, no, 0, 1, 3, 2, 4, 5, 7, 6. Now I'll mark the minterms. So the minterms are 0, 2, 3, 5. So this can be written as f of is equal to sum of minterms 0, 2, 3, 5. So I will have 1 here, 0, 2, 3, and 5, right? Is this correct? Or yeah, it's correct. Then I'll draw the check for chords. No chord possible, then I'll take the pairs. So I have this pair whose contribution is A bar B. Then I will have another chord like this covering minterm 3 and 7, whose contribution is BC simply. And then I have this chord whose contribution is A bar, and C bar. So my final output will be then equal to F is equal to A bar, F is equal to A bar B, this term, plus A bar C bar. I think I made a mistake here, right? Yeah, I made a mistake here. I have marked 7. This was not here. Let me just do it again. I think you should have corrected me here. Let me just do it again. So my f is equal to 0235. I had marked 7 as well in the previous one in place of 5. A bar A, this is B, B C. So this is B bar C bar, B bar C, B C, and B C bar. So 0 will be here, 2 will be here, 3 will be here, and 2 will be here, and 5 will be here only. Now we will construct the pairs. So this will be one pair whose contribution will be A bar B, right? Then I have another pair whose contribution will be this. This is again A bar C bar, and then I have this minterm that cannot be covered by a pair. So this is simply A B bar C. So my F will be equal to A bar B this term plus A bar C bar this term plus A B bar C. So this is A bar C bar A bar B plus A B bar C, that is option B. So option B is your correct answer. Any doubts? Actually I had written, yeah, numbering is wrong. Someone had written it. Yeah, so option B is your correct answer, right? Now we can move forward to question number 8 of today's live session, and let me just make it a bit big and move it here. So I marked it for this question for you guys to solve first, and then I'll show you the solution. So basically you have given this circuit and you need to find the output Z. So given is the circuit, you need to write the output. Just only type the correct option. No need to write the complete answer. Only type the correct option. Right. I guess all of you have done it correctly. So let me just show the solution. So we are given this circuit. So yeah, this A B C D. This is E F. This output, let me call it X1. So X1 will be equal to A B bar. This here right here X2. X2 will be equal to C D bar. X3 will be equal to E F bar. That is here. And these outputs are then given to a 3-input NAND gate whose output is written as Z. So Z will be equal to X1 dot X2 dot X3 whole bar. Plugging these values here. So it will be AB bar dot C bar D dot E F bar whole bar. Now using De Morgan's law, so it will be A bar, AB bar whole bar plus CD bar whole bar plus EF bar whole bar. So AB bar whole bar is simply AB using this property A bar dot A bar. A bar whole bar is A plus CD plus EF. So this is option B as rightly written out by most of you. Now I have this question which states that find the number of essential prime implicants. PI stands for, let me just write here, PI stands for prime implicants and EPI is your essential prime implicant. So you need to find the number of essential prime implicants for the given K map. So it is a 4 cross 4 K map and you need to find out the number of essential prime implicants in this. So how will you do it? We'll first mark the implicants, prime implicants. So first we'll look for the whether we have any octet here. Looking at it, we don't have any octet here, we can construct. Then we have chord. So we can construct a chord 0 like this. So this is my one chord, right? And the term that it gives is B bar, B bar. Check simultaneously. Then I have pair that I can construct this. Then I have another pair that I can construct, that is this. So these are prime implicants. And then I have another prime implicant, this. So these are my prime implicants, right? But the question asks us to how many of them are essential prime implicate. Can anyone tell me how many of them are essential prime implicate? Yeah, one of the student has written there are 4. So all 4 of the prime implicants here are essential prime implicate. So what basically is your essential prime implicant? So it is a prime implicant that covers a min term. So I'm talking about essential prime implicant. It is a prime implicant that covers a min term that is not covered by any of the prime implicants. So how we can look at it? So this min term 1 is covered by this prime implicant, not covered by any other prime implicant. This min term 6 is covered by this prime implicant and not by any other prime implicant. This min term 12 covered by this prime implicant and not by any other prime implicant. And then I have this min term 10. This is covered by the chord B bar D bar and is not covered by any other prime implicant. So all of the prime implicants here were my essential prime implicants. And one thing you can note is your essential prime implicants always appear in your final solution. So if you should remember this, your essential prime implicants always appear in your final solution. That is your final minimized solution. When you minimize the expression, your essential prime sorry about that, your essential prime implicants will always be there. So this was about this. Now moving forward to question number 10. The question number 10 states that the Boolean function f of abc equal to sum of minterms 3, 4, 6, 7 is equivalent to, I will again repeat this question. The Boolean function f of abc equal to summation of, that is sorry, the sum of minterms 3, 4, 6, 7 is equivalent to. So I'll give you a couple of minutes to solve this question and you can type your answer, then I'll show you the solution. Yeah, so I see a lot of you writing C. I'll tell you the reason why I put this question for you guys to solve first. So this is a three variable system function, and we have A and here BC. This is A bar and this is A. So this is BC bar. This is B bar C. This is BC and this is BC bar. This is 0, 1, 2, 3, 4, 5, 6, 7. So it is 3, 4, 6, 7. Let's mark the midterms. It will be this and it will be this. That's all. This should have been the solution, right? As one of the student had written. But you need to sometimes look at the wording of the question as well. The question didn't ask us to find the minimized expression. The question asked just to write the equivalent expression. So all of the options contains three terms. So there is some redundant term, and that is this term right here. First this term, and this term. So my F will be equal to contribution from this is BC, contribution from this is AC bar, and contribution from this term is AB. So this is equal to AB plus BC plus AC bar. AB plus BC plus AC bar. That is option C, as all of you have written correctly. Now next question, that is question number 11. So the question number 11 asks us, consider the following minterm expression for F equal to PQRS, where F of PQRS equal to sum of minterms 0, 2, 5, 7, 8, 10, 13, 15, and also the minterms 2, 7, 8, and 13 are don't care terms. So we need to find the minimal, that is the SOP form, minimized SOP form. So I'll again repeat the question. Consider the following minterm expression for F, where F of PQRS is equal to sum of minterms 0, 2, 5, 7, 8, 10, 13, 15. The minterms 2, 7, 8, and 13 are don't care terms. The minimum SOP form for F is, so we'll construct a 4 cross 4 K map like this, like this. I'm repeating these steps again and again because I want you guys to be very well practiced with this, and so that you won't make any mistakes in your assignments and exams. So this is PQ, this is RS. So this will be P bar Q bar, this will be P bar Q, this is PQ, and this is PQ bar. Then we have R bar S bar, R bar S, RS, and RS bar. This is 0, this is 1, this is 3, this is 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. Now I'll mark the midterms. So this is 0, 2, 5, 7, 8, 10, 13, 15. Right? These are my midterms. And there are also some don't care conditions. That is 2, that's already there, so I don't need to mark that. 7 already there, 8 and 13, so no need to mark them. Then let's see what we can do here is whether we can construct a chord. I don't think we can construct. So look for the, sorry, octet, we can't construct an octet. So look for the chord. So here we have this chord whose contribution will be Q because Q is not changing, and S because S is not changing. Then we will construct another chord like this, the corner terms, and the contribution from this is Q bar S bar. So my final function will be equal to in minimized form will be Q bar S bar plus QS. As rightly written out by some of you, it's option B. That is the correct answer. So just a general question here for a two variable system A and B, which is equal to A bar B bar plus AB. Do you know which logic gate this is? Which performs this functionality? What is this logic gate called? Correct. This is XNOR gate, or also called as exclusive NOR. And do you know what kind of functionality this does? So what can we do with this? It's using this truth table. What we can find out about the two variables? So using this gate, what is relation between two variables we can find out? Even parity. What's that called? Correct. Even parity is correct. But there is other term. I don't want to go into parity right now. But you're right. Even parity is correct. That's true, right. 100% correct. But what we can say about the two variables? So when XNOR gate has a high output, that is logic 1, what are the two variables equal to? I mean the relation, yeah, they are both like correct. The true variables are similar. That is A equal to B equal to either 0 or equal to B equal to 1. So, and what is the relation for XOR gate? This was for XNOR. What is the relation for XOR? It's A bar B plus A bar B plus, yes, A bar B plus AB bar. True for unlike, correct. We just wanted to give some idea about this. Now I have this question. I want you guys to solve it first, then I'll show you the solution. And one more thing. Today I saw some of the I don't know whether they were students or not. They were trying to enter the meeting by using some dummy names. I don't have any problem with the dummy names, but they should be having real human names, or at least some number corresponding to some ID and all that I can bear with, but not some anime characters or not some bike names and all. I won't be admitting that type of what should I say, that type of IDs. So I recently just now had a student. I don't know whether that was a student or not, having some anime name. So I didn't admit that person. So in case sometimes you might be logged in from your different ID, please check whether that has a real human name. So I want you guys to do this question number 12 first. So it says that f of a b c d equal to product of some terms, product of some max terms, that is the max terms 3, 4, 5, 6, 7, 10, 11, 14, 15, and you need to find what it is equivalent to. So I'll just give you a couple of minutes to solve it, then I'll show you the solution. Only type your correct option, don't type your complete answer. So I see a couple of answers. I'll just wait for 1 more minute for others to type in. Then I will show the solution. I guess no one is typing, so let me just show the solution. So we are given this f is equal to product of max terms 3, 4, 5, 6, 7, 10, 4, 11, 14, and 15. Now I'll construct a 4 cross 4 KMF for this. And here will be AB and here will be CD. So now since we are dealing with the product of max terms, some things will slightly change. So this will be A plus B, this will be A plus, this will be A plus B bar, this will be A bar plus B bar, and this will be A bar plus B, right? This will be C plus D, basically dual of POS. That's all. We need to do the dual. This will be C plus C bar plus D. This will be C bar plus D bar. This will be C bar plus this will be C bar plus, this was C plus, this was C plus D bar. This was C bar plus D. Right? Is this correct? Let me check it. A plus B, A bar plus B. Correct. And this is A bar plus B. Correct. Yeah. Now we need to fill the minterms. So it will be 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. Now fill the minterms. It will be 0. We write with 0. For max terms, we denoted with 0. In minterms, we denoted with 1. For max terms, we denoted with 0. So this is 4. This is 5. This is 6. This is 7. This is 10, this is 11, this is 14, and this is 15, right? Now I'll construct a chord for it. I don't see I can make an octet, so I'll just construct a chord for it. So I have these two apparent chords. One is this, and another one is this, and also I have this. The contribution from this will be A bar plus C bar, right? Because A bar is not changing and C bar is not changing. Then I am having another one here whose contribution is A plus B bar, simply this term. Then I have another one this here whose contribution is simply C bar plus D bar. So my final output minimized in minimized form will be A plus B bar, that is this term, then C plus D bar, that is this term, then A bar plus C bar, that is this term. So this is option A as written by some of the students. Is it clear for everyone? Are there any doubts with this question? So if you are given, for example, f of a, b, f of a, b, c, let's just consider a three variable function. Sum of minterms 1, 3, and 5. You don't need to solve it just for the example part. And you need to write its equivalent minimized POS form. So using K-map, how will you do it? Ignore the example, this part, ignore this part. You are given a function as a sum of minterms, and then you construct a K-map. Now you need to get the POS form out of that. How will you get that? Basically, there you will consider those terms that are not marked as ones. You will just label them as 0 and construct the chord, pair, octet out of those and write their corresponding max terms, like here. And finally, you'll have the solution. Basically, just doing this part. Now, a simple question for you guys. So, this here states that which logic gate is equivalent to these combination of logic gates. So, we have A and we have B. So, this is A and B. Can anyone tell me what this is equal to? Part A. Yes, this is equal to AND gate. This is basically your A bar. This is basically your B bar. And this goes to your NOR gate. So it is A bar plus B bar whole bar. So using De Morgan's law, it is A bar whole bar, B bar whole bar. That is equal to AB. So that is your AND gate. And what is this equal to? Can anyone tell me quickly? This one. Anyone? Yes, A bar. So basically it's a XOR gate. F will be equal to A bar AB plus A bar B bar. So A is A and B is 0. So it's A dot 0 plus A bar. B is 0, so it will be 1. So it will be A bar. F is equal to A bar. Also, other way of doing it will be just construct a truth table. This is your A, B, and this is your F. 0, 0, 0, 1, 1, 0, 1, 1. So for XNOR gate, it will be 1, 0, 0, 1. Your B was 0. So your B was 0. This part and this part. This and this. Your B was 0. Your B was 0 and your A was this. When your A was 0, F was 1. When your A was 1, your F was 0. So you can say that XOR gate, XNOR, behaves as a NOT gate if one of the input, if one of the input is 0, right? It behaves as a not bit. Now question number 14. The following K-map represents the function of f. The minimized form of the function f is, so again it's a three variable K-map. We need to find its minimized expression. So I'll just construct it here again. This is x, this is yz. So it's a bar, not a bar, this is x bar x, y bar z bar, y bar z, yz, yz bar. So it is 1, 1, 1, 1. So you will have, basically you can construct two pairs out of this. One is this one, other is this one. So the contribution of this is yz, right? This part, and the contribution of this is x bar and y bar. So my minimized function will be f is equal to x bar y bar this plus yz, x bar y bar plus yz. So option B is the correct answer. This was a pretty trivial question. By now you should be very well versed with this. So we have this question: in the sum of products x, y, z, sum of minterms 2, 3, 5, the prime implicants are. So f is equal to sum of minterms 2, 3, 4, 5. Three variable function. So we'll have this polynomial. So this will be x, this will be a yz. So this is x bar x, this is y bar z bar, y bar z, yz and yz bar. 0, 1, 3, 2, 4, 5, 7, 6. 4, 5, 7, 6. 2, 3, 4, 5. So 2, 3, 4, 5. So now let's looking for the pairs. So you'll have this pair and this pair. So these are the two prime implicants. So number of prime implicants are 2 and they are this term, that is x bar and y, and another is x y bar, x bar y and x y bar. So option A is the correct answer for this question. Now I have this question for you guys. So the question states that convert the SOP function f equal to x bar y bar z bar plus x y bar z bar plus x y z bar plus x bar y z bar plus x y z in POS form. So I'll give you a couple of minutes. I think it will take more than 2 minutes. I'll give you 3 minutes to solve this. Please type your correct options. Then I'll show the solution. So I see some of the answers. So let's write the function. F is equal to x bar y bar z bar plus x y bar z bar plus x y z bar plus x bar y z bar plus x y z. So f is equal to, this is basically 0 0 0. This is basically 1 0 0. This is basically 1 1 0. This is 0 and this is 1 1 1. So this is 0, 1 0 0 is 4. This is 6. This is 2 and this is 7. So basically this is sum of minterms 0, 2, 4, 6, 7. Right? So this is sum of minterms 0, 2, 4, 6, 7. Now we'll draw the K map for this. So here I am having x, here I am having z. This is x bar x, this is y bar z bar, y z, y bar z, y z and y z bar. So this is 0, 1, 3, 2, 4, 5, 7, 6. So it is 0, 2, 4, 6, 7. I have marked it as 1, 1, 1, 1. But what we need is we need to find POS form. So what I'll do, I'll just write the zeros. Here 0, here 0 and 0. Now I'll make the pairs out of this. So one pair I can construct like this. Another pair I can construct like, another pair I can construct like this. What happened? Just a second, just let me. So another pair I can construct like this. So the contribution of this will be, so now be careful here. So we need to find POS form, that is the dual of SOP form. So this contribution, if it was a POS form, SOP form, it was y bar z. But in POS form, it will be y plus z bar, right? And this right here, this would have been x bar z, but in POS form, it will be x plus, sorry, it will be x plus z, right? Let me just correct it, just a second. So this in SOP form would have been x bar z, but in POS form will be x plus z bar. So my final expression will be equal to f is equal to y plus z bar times x plus z bar. So option C, as many of you have written, is the correct answer. Now coming to the last question of today's live session, it states that given f1 equal to product of product of sum of max terms 0, 4, 5, 6 and f2 equal to product of sum of max terms 0, 3, 4, 6, 7, the maximum expansion for f1 and f2 is given by. So we have here is f1 equal to product of max terms 0, 4, 5, 6, and f2 equal to product of max terms 0, 3, 4, 6, 7. The max term extension for f1 and f2 is basically product of f1 dot f2. It will have terms, max terms that are either present in f1 or present in f2. So when you have a max term extension of f1 and f2 in POS form, its POS form will be the terms present either in f1 or in f2. So it will be 0, 3, 4, 5, 6, 7, either in this or in this. So that is option C. Another way of doing it will be f1. You can write it in SOP form, sum of min terms 1, 2, 3, 7, and f2 will be equal to sum of min terms 0, 3, 1, 2, 4, 5. 1, 2, 1, 2, 3, 3 is there, 4 is there, 5. Yeah, correct. And when we have f1, f2 as product, when we have SOP form, it will contain terms that are present either in f1 or in f2. Sorry, it will contain terms in SOP form. I'm talking about SOP form. It will contain terms that are present in both f1 and f2 when we are talking about SOP form. So it will be sum of that is 1 and 2. And if we need to convert this into POS form, what we will do? We will write those terms that are present here. So this will be 0, 3, 4, 5, 6, 7. So basically both of them are equal, and as a result your option C is your correct answer. So that was all for today's live session. If there are any doubts, please let me know. Otherwise, we can, what should I say? We can close this session. So today we discussed questions related to please differentiate between implicants and prime implicants. So is it a question you are asking about we have done, or it's just a definition? Okay. So I'll just go and check the exact definition. I don't want to give my own definition. I had once made notes about it last year. I'll just check them. Implicant. So according to the definition I have from, I think taken it from Geeks for Geeks. Yeah, implicant is a product minterm in SOP or external term. Prime implicant. Okay. Yeah. This is pretty simple. So you have a 4 cross 4 or 3 cross 3 map. Any term, 1, 2, 3, 4, 5, 6, 7, any term, it can be an implicant. So prime implicant is when you make a rectangle or you make a cube, or you, I mean to say, you make a chord, you make an octet out of it. That times it becomes a prime implicant, right? So according to the definition, prime implicant is basically a group of squares or rectangles made up of bunch of adjacent minterms, which is allowed by the definition of K-map. So that are called by prime implicants. So you have a K-map, you have some rules and regulations that time you need to follow. So the moment you follow those rules or regulations, you make a bunch of square or rectangles or whatever shape you want, that are called prime implicants. And implicants is simply the min term or the product or min term that is present in SOP form. It is the product term. In POS form, it is the max term. Right, you got it. So I'll tell you the exact definition. So an implicant can be defined as product or minterm present in SOP form, or sum or maxterm present in POS form. And prime implicant is defined as a group of squares or rectangles made up of bunch of adjacent minterms. Okay, what happened? Yeah, am I audible? Actually, I got disconnected from my laptop. What happened? Am I audible? Actually, I got disconnected. I'm connected on mobile internet now. Right now, I think there's some Wi-Fi issue. So I'll make it quick. I don't have that much mobile data left. Sorry about that. So actually, yeah, I'm connected on mobile data, and in hostel we don't have that much bandwidth. So our Wi-Fi, college Wi-Fi got disconnected. That's why. So I was just referring to this implicant. Basically, the min terms and maxims that are present are your implicants. And about the prime implicants, they are the set of bunch of squares, rectangles that you can create using the K-map rules. And then you have essential prime implicant are basically those prime implicants which cover the min term that are not covered by any other term, and they are always present in your final solution. So sorry about the connectivity issues. I guess we were done with our what should I say, today's part. I'll just check again whether internet is back or not. Yeah, I can connect to my college Wi-Fi. Just wait a second. I think internet is still not working. The college Wi-Fi is still not working. The institute Wi-Fi. So any other doubts? I'm not sure whether my voice is audible or not. So if there are no doubts, I think we can end this live session. So next time, what we'll be discussing? We'll be discussing logic gates more thoroughly. So the next live session will be based on logic gates. Yes, someone has raised a hand. If possible, can you please type it in the chat box? So actually, I have a limited bandwidth here right now. Can we solve number 16 by formula, sir? Can we solve number 16? Question number 16. So I won't be able to share screen. Actually, my internet is not connected to this iPad. So let me just check the question number 16. So question number 16. Which formula you are referring to? If you can, in using algebraic manipulations and all, you can do it most certainly. Basically, it will help you minimizing the circuit complexity. That's why. So the use of K-max, basically you need to minimize the circuitry. That will help you, because otherwise there will be some redundancy that will be existing. To avoid those, you can use K-maps to get the minimized solution, and as a result, the function that could have been implemented in a huge block, you can use just the simple block to implement it, right? So any other doubt? If not, I think we can end this meeting here, and we'll meet next time at 3 o'clock, and we'll discuss logic gates. Thank you all for joining. Thank you. See you next time.